this one is an alternating series, and so maybe I might want to even pretend this is on the test and say, okay, does it converge? Although they've kind of told us it does. I'll say, does this series converge? So once I see that -1 to the n, I'm thinking I should try AST. If this meets the two conditions for AST, and maybe you could say there's three conditions. One is it has to be alternating. So let me say try AST since the series is alternating. So for AST, one condition is this, and I'm going to phrase this as a question. Is B sub n plus 1 less than or equal to B sub n? I'm going to rewrite my little series here. So as I have B sub n kind of right there, I can't mistake it. There's the alternating part. And so it's 1 over 2n factorial. So B sub n is 1 over 2n with the factorial on the outside of those parentheses. Here is B sub n. Then B sub n plus 1 would be 1 over 2, and I'll open parentheses. The n becomes n plus 1. Let me put that whole thing around parentheses because factorial's on the outside. Is that less than or equal to 1 over 2n factorial? Here, I'll phrase that as a question again.
Yes.
Yes. The denominator is getting bigger and bigger, so the fraction's getting smaller. The numerator's staying a 1. If the numerator were changing as well, I'd have to maybe think about it a little bit harder than I did. But since it's just the denominator getting bigger, the fraction's getting smaller. So that's true. And the second part, what about the limit as n approaches infinity of B sub n? This would be the limit as n approaches infinity of 1 over 2n factorial. Is that 0? Yes. So I'll just put a little check mark there. I meet the two conditions of AST, so the series converges. If it doesn't meet the two conditions of AST, then try the test for divergence. Well, this problem, they pretty much told us in 27 that it converged. When they say approximate the sum, they're implying that it converges. So let me find the sum to 4 decimal places. And for this, I would write out some partial sums. There are several ways you could kind of attack this problem, but to find the sum to 4 decimal places, I'm going to start off by writing out a few partial sums. Yes. You're welcome. Thank you for asking. All right. So S sub 1 would be the sum as n starts at 1 and stops at 1 of -1 to the n over 2n factorial. So S sub 1, n would be 1. I would have negative 1 to the first over 2 times 1, which is 2, and that number factorial. Well, that's going to be just negative 1/2, right? So negative 0.5. I probably want to look at it in decimal form. S sub 2 is the sum as n goes from 1 to 2 of negative 1 to the n over 2n factorial. So that's going to be, when I plug in 1, it'll be negative 1/2. And when I plug in 2, then negative 1 to the second power is positive. And then the bottom is 2 times 2 factorial. So that is negative 0.5 plus 1 over 4 factorial. And 4 factorial would be 24. So let me get the decimal for this. So negative 0.5 plus 1 divided by 24, and I get negative 0.458 repeating 3. And then I'll go for S sub 3. Now, after I find S sub 3, I'm going to raise a question that somebody did ask yesterday or in my office. S sub 3 would be negative 0.5 plus 1 over 24 plus the next term. So, in fact, I'll just write negative 1/2 plus, when n is 2, it's 1 over 4 factorial. 4 factorial is 24, so 1 over 24. When n is 3, it is negative, so it would be minus 1 over, this would be 2 times 3 factorial. So 2 times 3 is 6. Negative 1/2 plus 1 over 24. Now 6 factorial, I'll do 6 probability, underline factorial, press equals, there it is, equals 720. So minus 1 over 720. So I'll have negative 1 divided by 2 plus 1 divided by 24 minus 1 divided by 720. And it is negative 0.4597 repeating 2. Somebody did ask in the office, can you skip around? The answer is yes. You can. If you're thinking you want to go all the way to S sub 5 or S sub 6, you can go there. And when do you know you've gone far enough? You can actually check the B sub n's, maybe B sub 5, B sub 6, B sub 7, see what the value of that number is, and that'll tell you if going that far is far enough. So if I check that, let's say check the value, check the values of some of the B sub n's. I'll put this in chart form. B sub n, maybe I need a column for n. So let's check 5. B sub 5. Now the B part is just this. I don't have to worry about the negative sign for this. So B sub 5 would be 1 over 2 times 5 factorial. So I'll write the decimal out right here. 1 over 10 factorial, and in the calculator, 1 divided by 10 probability, underline factorial, press equals. I got 0.12345 1, 2, 3, 4, 5, 6 zeros, 276. So the number you add or subtract gets smaller and smaller and smaller. So when I get up to S sub 5, the sum, my partial sums, are changing very little. It would be accurate within 4 decimal places at that point. So I've already found S sub 3, and I'm figuring, just by looking at B sub 5, that S sub 5 is going to be close enough. And in fact, on the WebAssign, they're wanting you to answer how many terms, what is the smallest number of terms you need to get such a, whatever accuracy they're asking about. If you go more than enough terms, you're still safe. You still have the partial sum with that accuracy. So I would say, like S sub 5, okay, it's negative 1/2, the first term, plus 1 over 24, that's when n is 2. When n is 3, it is minus 1 over 720. When n is 4, it will be plus 1 over, now 2 times 4 is 8, so that's 8 factorial. When n is 5, it's minus 1 over 10 factorial. And if you find this decimal, that's going to be close enough to 4 it'll give you an accuracy within 4 decimal places, because I know this little number is point with 6 zeros and then 276. So I know that it's not going to change within 4 decimal places at that point. And possible, I was okay right here. I'm looking at it and I'm thinking I'm going to go further than what I need. Negative 1 divided by 2 plus 1 divided by 24. I'm finding S sub 5. Minus 1 divided by 720. Plus 1 divided by 8, probability, factorial. Minus 1 divided by 10, probability, select factorial, and press equals. And I got negative 0.4596976. 4596. I'm just double checking. 976. There it is. Okay. And I know more partial sums are only going to affect decimals that are further out. So what is this to 4 decimal places? To 4 decimal places, S, now I'm talking about the sum, S is what? Negative 0.4597. I would go ahead and round up. On the test, if you give more than I'm asking for, I'm okay with that.